All is well. So today we're talking about the Pythagorean theorem. Now, I know that this is a middle school content. You definitely learned this in 8th grade. Who can tell me what the Pythagorean theorem is used for? Ken? No, but you're close.
Find the perimeter of a triangle.
No. Okay, let's start with the I can statement. And I apologize, my stylus was not great while I was at home. So I can use the Pythagorean theorem God bless you. To verify right triangles and find missing sides of right triangles. So I can use the Pythagorean theorem to verify right triangles and find the missing sides of right triangles. So the Pythagorean theorem is used to, first of all, if you're given three measurements, three side lengths of a triangle, you can tell without a picture if that's going to be a right triangle or not by using the Pythagorean theorem. So the first thing that we want to do is we want to label some of the things on this right triangle. So how do I know that this is a right triangle? Where? So right about here. This is a 90-degree angle mark. That means that it's a right angle. Okay. That's what that little square inside of there means. When we think about a right triangle, we kind of name the pieces. So the two sides of the right triangle that make the right angle are called the legs. So this is a leg, and this is a leg. Those two sides come together to form the right angle. What about the side that's opposite the right angle? Do you guys know what that's called?
Straight that I remember, but I can't remember what it's called.
Begins with an H. Hypotenuse. Have you guys heard that before?
Yeah, I have.
It's the hypotenuse. Okay. So when we think about the Pythagorean theorem, what the Pythagorean theorem says is that the sum of the squares of the legs is equal to the square of the hypotenuse. So we say that the legs, we call one of them A. Oops, I did not want to do that. I don't want it to be a shape. One of them A, and we label the other one B, and the hypotenuse is always labeled C. Now, sometimes it's tricky to figure out. Sometimes you can mess yourself up using the Pythagorean theorem if you don't label your sides appropriately. So I always recommend that you start by labeling the hypotenuse first. And I kind of use this right angle in the corner as a guide, and I always draw an arrow across. Because I know the hypotenuse is opposite. It's the side opposite the right angle. So I draw that arrow and I start with C. And then the legs, A or B, doesn't matter which one you call A and which one you call B. Okay? So the sides, the sum of the sides, that means we're going to add them up. The sum of the squares, after we square their measurements, equals the square of the hypotenuse. So we're going to start with a word problem because that's pretty much what all of our Pythagorean theorem models are about, real world applications. And here is the Pythagorean theorem. The a squared plus b squared equals c squared. Hang on a second. It'd be nice if I could spell that. So anytime we start with a word problem, I want you in your brain to kind of be thinking of a sketch that we can do. Okay. So Adrian is standing on the ground 12 feet from the base of a tree that is 5 foot tall. So the first thing that I'm going to do is I'm going to draw a tree. And I know that the tree is how tall? 5 feet tall. Okay. Okay. Adrian is standing on the ground 12 feet from the base of the tree. So that means that Adrian is like, God bless you, standing right over here. And the distance from Adrian to the base of the tree is how much? 12 feet. Okay. Sophie is standing on the ground 8 feet closer to the base of the tree than Adrian. So if Adrian is 12 feet away, how far away is Sophie?
4 feet away.
Sophie's 4 feet away. She's 8 feet closer. So here's little Sophie, putting her in a little skirt, tutu thing, I don't know. Maybe it makes her look like she's got a spider, who knows. And her distance is 4 feet. Okay. What is the distance from Adrian's location on the ground to the top of the tree? What is the distance from Sophie's location on the ground to the top of the tree? So we're asked to find this first, and then we're trying to find this second. Well, I'm just going to draw a right triangle so you can really see what's going on. So my first one with Adrian has a measure of 12 and 5, and we're trying to find this measure right here. So where's the right angle live on this one? Where does the right angle belong on that triangle? Where the base of the tree meets the ground. Yes, right here. So what is the hypotenuse?
So the hypotenuse is y.
Y. The hypotenuse is y, what we've labeled y. So the legs, A and B, and the hypotenuse is C. But I'm going to use the numbers and the variables that we've put in here. So when I use Pythagorean theorem, A squared, that's 12 squared, plus B squared, that's 5 squared, equals C squared. Well, that's going to be Y squared. Okay. So what is 12 squared? Yeah. Yeah, good job. 144 plus 5 squared is
25.
equals Y squared. So what is 144 plus 25?
169.
So 169 equals Y squared. How do I figure out what Y is? I have to unsquare it. How do you unsquare something? The square root of it. Good job. So Isaac says we have to take the square root of it. But remember, with equations, whatever you do to one side, you have to do to the other. So I know that the square root of y squared is y. What is the square root of 169? How do I find that on my calculator? Where's the square root button live on your calculator? So if everybody picks up their calculator, I want you all to find the button that says x squared. Does everybody see the x squared button on their calculator? Okay, do you see right above it? It has a little blue drawing of a square root symbol. All of those blue items on any that are above any of the buttons, the only way that you can access them is by hitting the second button, right? So we're going to hit second and then press the x squared button. And that will give us the square root symbol. Second x squared. And then you're just going to type in the number 169 and press enter. 13. So Adrian is 13 feet away. Let's figure out how far away Sophie is. Okay, so Sophie's triangle, a little bit smaller, right? She's got a much narrower base. So Sophie was 4 feet away. Tree is still 5 feet tall. And I called this X. How are we going to set this one up? Where's the right angle? Go ahead, Owen. Yeah, it's where those two legs meet, right here. So how are we going to label our sides? Which one is the hypotenuse? X. Good job. So does it matter which one I call A and which one I call B? It doesn't. So what's this equation that we're going to write look like? A squared plus B squared equals C squared. What's that going to look like? Go ahead.
4 squared plus 5 squared equals 6 x squared.
Perfect. 4 squared plus 5 squared equals x squared. So let's see. 4 squared is 16. I heard someone whisper it. 5 squared is
25.
And x squared is just that. X squared. What is 16 plus 25?
41.
So 41 equals x squared. So what are we going to do to solve this? Take the square root of both sides. Good job. So I know that the square root of x squared is x. What is the square root of 41? So it's not an exact number, is it? So I'm going to say that x equals the square root of 41. And then I'm going to say x is about, and I'm going to use a squiggly equal sign. That's an approximation. I'm going to say 6.4. So Sophie is 6.4 feet away. How do we feel about that? Good? Okay. Flip over. So these are kind of like some doodle notes. All right. So the Pythagorean theorem is used to find the side lengths of a what kind of a triangle? Of a right triangle. So that's the first thing that we're going to put in here. Of a right triangle. Okay. Do these side lengths form a right triangle? So this is an example of how we would verify that we have a right triangle. So I don't have a picture here. How do I know which one is going to be C? How do I know which one of those should get the labels of A and B and which one should be the C?
So A should be 8 centimeters. B said should be 10 centimeters and C should be 13 centimeters.
Why do you think that?
Because if it's A, B, C, 8, 10, and 13 get larger each time.
So you're telling me that the largest side is always what?
Is always C.
That's what I wanted to hear. Perfect.
I thought you'd say I was saying correct.
No, you were right on the money. The largest side length is always C, the hypotenuse. Okay. A and B doesn't matter. Doesn't matter if you call 8A or 10A. Doesn't matter. We're just going to square them and add them together. So I have 8 squared plus 10 squared. But it's important which one you call C. It's always the longest side. Equals 13 squared. So let's see. 8 squared is,
64.
and 10 squared is,
100.
okay. And 13 squared is,
Is 169.
so let's see. 100 plus 64 is 164. Does 164 equal 169? No. So this is not a right triangle. Not a right triangle. Okay. What is the Pythagorean theorem? Someone tell me what we're putting in here. Go ahead.
I'd say it's the formula.
Yeah. What is,
Solve a right triangle.
so what is the formula?
A squared plus B squared equals C squared.
Perfect. Okay. I'm going to keep moving around to the right. So label the parts of the triangle. How are we going to label the parts of the triangle? Think about how we did it on the front page. Go ahead, Owen.
The hypotenuse is the only side that does not touch the little box in the corner.
Yeah, the hypotenuse doesn't touch that right angle at all. So that means that this is my hypotenuse. The hypotenuse is always opposite that.
And A and B, A is the base, the flat part, and B is the part that goes vertically.
Okay, what do we call those? They're called the legs. Good job. And then we talked about this little box. What do we call this? Yeah, it's the right angle. It represents 90 degrees. Okay. How do we feel about that? Okay. Find the diagonal of the quadrilateral. Find the diagonal of the quadrilateral. So the diagonal is this right here. And this looks like a rectangle, and I say that because I've got a right angle in the corner. I know that the height is 9 centimeters and the base is 12. So I'm going to put that 12 centimeters down here. So do you see that we formed a triangle? So the diagonal that I'm looking for is actually the what measure? Is it a leg or is it the hypotenuse?
It's the hypotenuse.
It's the hypotenuse. Yeah, we're trying to find C. So how are we going to set that up? Someone other than Owen. Aiden A. How are you going to set that up? Okay. Lissandro. How are we going to set that up? Say again? Yeah. So which one do you want B and which one do you want A? Yep. We're doing this box. Yes. Say again? You want to call the one on the bottom A? Okay. So the guy on the right, B. So what's it going to say? How are we going to write the equation? What's that going to look like? Equals C squared. Good job. Perfect. So what is 12 squared? 144. And 9 squared? Equals C squared. So what is 144 plus 81? So 225 equals C squared. How do I get C all by itself? Whatever you do on one side, you have to do on the other. So C equals what? 15. And the units are going to be the same. So the diagonal is 15 centimeters. All right. Do we feel okay with that? All right. The Pythagorean theorem works two ways. If the triangle is a right triangle, then a squared plus b squared equals c squared. It also works such that if a squared plus b squared equals c squared, then the triangle is a right triangle. Meaning that you can be told that you have a right triangle, which allows you to use the Pythagorean theorem to find a missing measure, or you can take all three measures and prove that you have a right triangle. It's reversible. Okay. All right. Example number 4. It's given us two ordered pairs and asking us to find the distance. And that's the first time we've ever done anything like that. So let's see. Our first ordered pair is the ordered pair -3, -1. And our second ordered pair is the ordered pair 5, 5. And it's asking us to find the distance between those 2 points, meaning the length of this segment. But what do you notice that you can do? I can make a triangle out of it. Good job, Isaac. I am going to make a triangle out of it. I'm going to make a right triangle out of it. So where does the right angle lie, Isaac? Yeah, the bottom right corner. Here's my right angle. So now I can just count the grids to figure out the length of A and B. So A is 1, 2, 3, 4, 5, 6, 7, 8 units long. And B is 1, 2, 3, 4, 5, 6 units. And we don't know what this distance is here. I'm going to call it D for distance. But can we figure it out? Yeah, what are we going to set up? Isaac, you set this one up for us. Yeah, 8 squared plus 6 squared equals D squared. So 8 squared is, 6 squared is, equals D squared. 64 and 36 is 100. I have to take the square root of both sides. And when I do that, I find out that the distance between those two ordered pairs is what? It's 10 units. The distance is 10 units. Okay. All right. The lengths of the blank are represented by A and B. What are we putting in that blank, Daniel? How did we, when you think about how we labeled our triangle off to the right, what did we call the sides that are A and B? The legs. Good job. The length of the blank is represented by C. What did we call, what would that? Hypotenuse. Good job. And what is always the longest side of a right triangle? The hypotenuse, yeah. That helps when you don't have a picture. That helps when you don't have a picture. Okay. Sir. Yeah, I would love that. Come stand over here by me. So find the missing side length. So what are we missing? Are we missing a leg or are we missing a hypotenuse? We're missing a hypotenuse. We're missing a leg. Yeah, we're missing a leg. So what do you want to call this missing piece? Do you want to call it A or B? B? Okay, sure. So how are we going to set this up? Someone who hasn't shared yet. What do you got, Tim? 4 squared plus B squared equals 5 squared. Okay. So 4 squared is plus B squared equals 5 squared. This is the first one we've done like this. Oops. I need to turn that 5 squared into a 25. Sorry. Yeah. So now what am I going to do? Because I'm just solving an equation. What would you do next if you're trying to get BL by itself? Yeah, subtract 16 from 25. Good job. We're going to subtract 16 from both sides. So B squared equals 9. And then what? Square root it. Yeah, square root of both sides. And we find out that B equals 3. So the missing side length is 3 inches. It's not squared. It's just 3 inches. Don't forget your units, okay? So there's something very unique about the 3, 4, 5. 3, 4, 5 combo is called a Pythagorean triple. And a Pythagorean triple is just a set of 3 integers that make a right triangle, okay? So the cool thing about the 3, 4, 5 is not only does 3, 4, 5 work, but any multiple of that. Like if I multiplied all those numbers by 2, that would give me 6, 8, 10. Or if I multiplied all of those numbers by 4, let's see, 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. And so on. 3, 4, 5, and any multiple of that is probably the most common Pythagorean triple. But there are 100 of Pythagorean triples, hundreds of them. I'd say the next most common one, and we used it today, is a 5, 12, 13. The cool thing about Pythagorean triples is not only does that integer combination work, but any multiple, meaning you can multiply all those numbers by 2, all of those by 3. So 15, 36, 39 would also work. It's pretty neat. Okay. All right. I think that's everything on our little foldable, right? Okay. Good deal.